Hello to our talk, Configuration Management versus Container Management. This is Arnold and I'm Johannes. And now we'd like to introduce ourselves a little bit. And Arnold begins.
Hello everyone, I'm Arnold, working as systems engineer at inovex from Germany. To sum it up, what is listed on the slide, I'm doing lots of stuff in the software-defined data center area, so configuration management, continuous integration, continuous delivery pipeline for development teams, and the setup of high available platforms, websites, and all this stuff. And yeah, Johannes.
I'm a student and I'm also working at inovex with the focus on research and development in the field of software-defined data centers, so everything from software-defined storage to software-defined networking. I'm working with containers over a year and I focused on the problem of orchestration and scheduling. And also I'm working at a project where I can get real-life experiences and not only the research and development world. So, in short, our agenda. At first we would talk about our motivation behind this talk. Then we would show some pitfalls and some lessons learned. Then we would show some use cases where you can combine both worlds, or where you should use which world. And in the end, we have our conclusions. And of course, we have a Q&A session. But if you have some questions, you are allowed to ask us at any time. Just raise your hand.
Our motivation. Johannes and I have several, but mostly different backgrounds. Since he is using some cool new shit like containers, Docker, orchestration, tools like Docker and Kubernetes for about or more than 1 year. In his student time, he has the opportunities to work with new technologies, and I am working for some years as systems engineer in projects for customers. And my day-to-day job is mostly about configuration management. I'm working with a lot of tools like Puppet, SaltStack, Rex, and so on. And yeah, we had some discussions once a year ago, and we just thought maybe we could share some ideas and some lessons learned. So this talk is the goal or the product of our discussions, and yeah, we would like to talk about it. What we have shared and what the shortcomings and benefits of these tools and techniques are. So let's switch to more technical stuff like the pitfalls that we see, that we have trapped in and that we saw, and maybe some tips and recommendations how to prevent them. Lessons learned. So at first there's the phrase configuration management sucks. So people are arguing that configuration management takes a lot of time. Configuration management is software development at its best. You need to have knowledge about, in software development, you need to need to have some experience with version control systems like JIT. From time to time, you need to refactor code. You need to spread out your knowledge with your colleagues using pair programming and similar techniques. And yeah, if you have a growing project or a large project, you also probably need to have a continuous integration and continuous delivery pipeline or setup using Jenkins and similar tools. So system administrators start to develop code, and also some people are speaking about or see that there is a lot of over-engineering in configuration management, since you often try to make your Puppet modules or source formulas, chef recipes, Ansible playbooks, and so on. You try to make them open source to distribute your public code on Puppet Forge, GitHub, and so on. You tend to try to make your code for as much user as possible usable. So you have very generic code, and maybe you don't need this generic code in all of your projects, and maybe it doesn't make sense to make them public. So what you need to keep in mind is when writing such modules and such code is to keep it simple, stupid, or keep it simple, short. Maybe it doesn't always make sense to make those modules public. And be careful, because such modules can be too generic, and admin's code can become pets, which pets are nice, but probably some of you may know pets have their disadvantages. We will come later on this topic. And the third point, another great phrase, configuration management, is legacy or legacy OS management. So if you start to maintain hundreds of systems, let's say virtual machines, EC2 or VMware and so on, you manage hundreds or thousands of hundreds userland spaces, userland tools like wget, curl, and so on. Many tools that exist in operating systems and Debian, CentOS, and so on, Red Hat, but you don't need them to operate or to run your application. A Tomcat application server doesn't need wget or curl. So you have a lot of other stuff that you need to maintain. You need package management or patch management to keep all of your stuff up to date. And maybe there's maybe lightweight containers can be an advice or a solution or help on this. So you would create containers, you would use something like Docker to have lightweight containers that isolate processes, that isolate software, and reduce the OS overhead or the userland tools that you need on your admin station, but don't on the servers itself. Kettles are better than pets, but kettles are heavy and time-consuming too. Maybe we can discuss about it later on. Johannes.
So the containers have also some pitfalls. One of the biggest is that Docker is still a hype. So it's a relatively new technology, but basically it's just old wine in new bottles. And there are really less success stories, or the success stories you get or hear about it are mostly from some young startups in America. So Docker gives you a lot of opportunities, but you have to choose your stack very wisely. So there are many tools popping up around this Dockerversum or in this environment, and you have to think about what tool should I use, because there can come some big bang changes. So for example, there are changes in the API which would destroy your current settings, or even worse, the project doesn't get maintained and you need to go to another tool stack. So the solution for this problem would be take very careful look at your tool stack, what you choose, and look at the maturity of this tool stack. So for example, if you look in the orchestration part, something like Swarm or Kubernetes or Mesos would be pretty nice. And also there's a lack of well-known standard, open standards. There is now the Young Open Container Initiative, but there aren't very much things done at the moment. And also in the network space, for example, we have two different standards, one from CoreOS, the CNI, and one from Docker, the CNM, which are focused on different layers. So Docker security is a mess. Basically, what we mean is that you need a basic understanding of C groups, capabilities, and namespaces, so that you can set these exactly for the needs of the application inside of the container. And if you really need a hard separation, you need to ensure this by physical separation or by putting containers into a virtual machine, or even don't use containers. And also you need to talk and work with your devs so that you know what they are putting inside of this container and what do they actually need to run the applications they are programming. In the next point, we say that images on the Docker Hub are insecure. So mainly we are talking about the community contributions, and it's a little bit like the Puppet Forge, or you have to take a deeper look at this image, and you have to think about it. How do they maintain this image? So when he just uploaded one image and never did anything else on this image, you shouldn't use it. You should also build your own images if you can. So they should be lightweight with as less as possible user land. And for example, you can use the base image like Debian, Alpine Linux, or CentOS, and you can build on top of these images. And when you're thinking of Docker images, you have to think like artifacts or like a package. And basically, a Docker image is nothing else than a virtual machine image or like a package in the Debian and LPM world. So if you use some official images, you have to trust the people that are building these images.
Right. Docker files should be public. So if you're using any images from Docker Hub, take care of Docker files. Take a look at it. If you plan to use those images in your own environment, in a critical environment, right, or just build your own. Okay, we talked about over-engineering and configuration management. So there's configuration or over-engineering in the Docker or in the container world too. People say Docker is the return of the bash, or brings the return of the bash. There are some very complex and heavy Docker files that have a lot of bash scripting, that are Docker files that are large or long, and use a lot of bash magic to install a lot of software, or install software that isn't needed. And yeah, if you remember, bash scripts, configuration management was built to replace those bash scripts from production and so on. People should stop using shell scripts and switch to configuration management. And the potential or the risk of falling back to the old principle is very high. So what you should do is to try to prevent large Docker files. Try to separate your software, your processes into dedicated images. This doesn't mean that you have to separate one process per image, but try to isolate. The benefits of it are separating for security, so processes have less access to other services or processes, and the maintainability of Docker files improves. If you have large shell scripts where you think they are needed, and if there's not a lot of space or potential to improve them or to reduce them, to make them smaller, think about using configuration management tools that we already use to set up those images, but keep in mind that you shouldn't install unnecessary modules in your images to run your configuration management system that aren't needed later on. So maybe it should be useful to run configuration management outside the container. Or a very lightweight configuration management tool within your container that you can easily remove later on before the image build is done. Scheduling and orchestration is a whole new area. We had some talks about today and yesterday concerning orchestration, orchestration, who does even need it, and if you start to have lots of containers that are deployed and started very rapidly and are removed very fast and rapidly, you would like to start to fully automate this process, this life cycle of containers. And this is a point where scheduling and orchestration will be very important. And in the container world, if you have known orchestration beforehand, for example, in an OpenStack cluster, orchestration in the container world will add a new level of challenges and difficulties. If you start to use containers or Docker, maybe just keep it simple, stupid in the beginning. Try to migrate very smoothly, step by step, to Docker, and try to implement a very simple solution for orchestration or scheduling. Make your experience with these technologies, and maybe at some point you could start to use tools like Mesosphere, Kubernetes, and so on. This applies to also other areas of operations, of IT operations. Do it stepwise, avoid big bang changes developers don't start to claim on you or to start to bell on you because you change everything and APIs and interfaces break. So we talked about pitfalls and some lessons learned that we had. We would like to continue with some use cases, and Johannes will tell you something about an example setup that we can imagine or that we inovex already have in work.
Yeah, so we would like to point out where maybe makes configuration management sense. So when we start on the left side, we use some buzzwords, so private and the public cloud. And when we go above, we have our infrastructure as a service or our platform or container as a service. So when we now start in our private cloud, for example, and we want to provision our bare metal host, what we need is obviously configuration management, because we want to install our hypervisor and some other tools like for hardening and network configuration, for example. And when we have this step, we can go ahead and deploy onto these bare metal hosts virtual machines. And inside these virtual machines, we also want configuration management, because when we deliver a virtual machine, we got some requirements, for example, so that there should be a running Apache with some special configuration, and you don't want to do it by hand or with a bash script. And to get another feeling, you can start and deploy a dedicated virtual machine and deploy your containers. Then you can play around with containers and get a feeling. And also when you try to deploy a more complex container, so for example you want to put something like a pre-EPA or something bigger into your container, you can consider to use configuration management to provision this container from the outside. Actually, I wouldn't recommend using configuration management in the container, but maybe there are some use cases where you need to use configuration management in your container, or where it makes your life much easier. And in the next step, you can go ahead and create or use a cluster scheduler on top of your infrastructure and run these containers on bare metal if you don't have the need for physical separation. At the end, it's important that we focus on our application because at the end of the day, our customers pay us for our running application and not for our cool infrastructure. So don't forget that the infrastructure is just a mean to the need. So don't over-engineer your infrastructure and take it as easy as possible, because you need to maintain your infrastructure also.
And when it comes to introducing something like Docker, you can see with these arrows here that you can do this stepwise, start with containers on virtual machines, maybe switch over to use CoreOS as operating system on the infrastructure as a service side. And yeah, maybe if you need it and it makes sense to you, you can also switch to own or public, also externally hosted private as a service, container as a service services, and make your path to containers. So if there are anybody of you thinking about containers, and if you ask yourself, why do we even need containers? There are some use cases where it can be very useful for you. So just imagine you have a setup, let's say an email platform, an infrastructure that allows users to create or to register new email accounts, like Gmail. You have a webmail system, you have a mail infrastructure, you have databases internally used by those components, front-end systems, middleware systems, back-end systems, and so on and so forth. And if you tend to have, let's say, if you plan to add large or if you start to have integration tests on those components, where the middleware and the front-end systems, for example, require a database, MySQL database, and a Dovecot IMAP server, and maybe a postfix MTA, you don't want to run those components, those software on Jenkins itself if you're using Jenkins for continuous integration. You can move those software like Dovecot, postfix, and also your application itself into dedicated containers to reduce the amount of dependencies to your host system, in this case the host which runs Jenkins, to run your tests. If you move those components, even the integration tests, into your containers, you could also make use of the portability of Docker images, and to run those containers on your notebooks itself. Another point or use case that we see are this microservice thing. So if you have a team, developers, that plan to change the software architecture or plan a service architecture where there are big and maybe tiny services or small services that come and go in a very short time, you can make use of Docker, which speeds up your deployment very fast. So if you have short-living containers, your management overhead and maybe the time to spawn and to deliver the services, these containers, is even faster compared to fully virtualized virtual machines. And another use case that we see is blue-green deployment. Imagine you have a three-tier architecture, front-end, middleware, backend, and you want to roll out a new software in your middleware layer. You can spawn a separate Docker or container infrastructure that runs the middleware application in the new version, and you can move your production traffic, your actual users, to the new system, to the new containers that running the new application version, gain some user feedback, see how it works, and if you need to make a rollbacks, you can easily move back to the older version and start to make the new version more to fix some problems on the side. Some people also call this immutable infrastructure. We have a lot of cool benefits that we can earn here, but this is not a topic. So in the end, we would like to come to some conclusions.
Yeah, so the first conclusion for us was that containers aren't a holy grail, but they can enhance your architecture. So the main thing was that never try to solve all your problems with just one technology. So you always have to choose the right tool for the right job. To run containers, obviously, we need some bare metal or something where we can manage them. And for this step, you probably will need, in the most cases, something like configuration management. The next point, that containers have lower overhead compared to VMs. I think this is a point which is clear to everybody here in the room, is that you now have the ability to use it on your local machine, and also you can use these containers to test, for example, your configuration management. If you use a container and install, for example, a salt min in it, and then you can test your salt script, salt formulas. The next point was actually pretty funny to us, that containers and configuration management share the same problems. So we have to think about the user land and the patch management. So what do we want? In both worlds, we want to minimize the user land so that something identifies or needs a patch for a fix. Then if you have very less user land, then the probability that we are hidden by this accident is very less.
And also, when we speak about configuration management, of course, you want to automate important workflows to set up your machines automatically. We talked about it. Containers won't work without dev and ops corporations. This is a very hard dependency. Forget it. When you don't want to work with your colleagues, you have to. In the container area, you really sit together with your development colleagues, speak with them or to help them to create good Docker images in terms of mostly secure images and easy to maintain images. This is very important. Also for running your application that you develop itself, it is very important to help your colleagues and to help to understand which points are important in when you operate or you run your applications in a production environment. There are many Docker images in the Docker Hub, and I would say that a lot of them aren't shouldn't be used in production because some containers have a very large or very impressive development site or are built from developers, and some ops recommendations should be applied to them. So after you have started setting up your virtual machines using configuration management, virtual machines are the next and last possibility to actually work with your colleagues. Right, and our final conclusion is containers and configuration management systems will coexist. We never try to solve our problems, all of our problems, with just one single tool. We try to use the right tool for the right job, and there are points that speak for containers, but also points for configuration management. And if you are able to choose the right tools for your jobs, yeah, you can sleep very good at night. So this was a talk. Before we want to head over to the Q&A session, I just want to speak to our German configuration management camp attendees. We are looking for colleagues. So if you're from Germany, would like to work in great projects with a lot of open source software in or very different departments, just speak to us. If you have any questions regarding the talk too, just come over to us. We are still here until 6 p.m. or so. So if there are any questions, please raise your hand. I think we have